Hey everyone, it's Anirudh, and we're going to be working through midterm 1, question 7, part B in this video. Similar to the last part A, I'm going to be working through it as I was taking it on an exam. So I'm not going to just reveal the answer, but we're going to work through it and determine how to get to that answer in the first place. It looks like this question is expanding on what we did in part A. If I look at the right, we're filling in more skeleton code. If I look at the paragraphs, sort of the mini spec, if you will, it says that we need to finish implementing the water bottle class. That way it is a container. Is bolded, which makes me think of how things have to be is a, not has a, about the subclass, superclass relationship. And then effectively, what I need to do is fill in the pour method and the class signature. Okay, and then this next paragraph looks to be a description of what the pour method does. We pour an amount into a container, and then we have to return the amount of excess liquid. So if it overflows, how do we determine if it overflows? Well, there's a capacity associated with it. And then it gives us an example. Maybe we can use the example. So if you're doing this at home, or if you haven't done this question yet for some reason, I would strongly encourage you to try drawing this out. I'm going to be going through this example at the very end to show why our solution works. But I think it's very useful when on paper to just go through the example and sort of understand what's going on. Specifically in this case, if we had the amount filled as 5 and then we're pouring in 7, now we have 12. And since 12 is over the capacity of 10 by 2, we return 2 and we keep the capacity at 10. So let's start. We need to first fill in the class signature. So since container is an abstract class over here, how do we work with abstract classes when we want to create a subclass for them? Well, we use extends. The other keyword that you might be thinking of is implements, but we would not use implements because implements only applies for interfaces. It might be a little bit confusing because we're also overriding here, but that's just because this is an abstract method. So now let's get started with the other part, which is that we need to create something for pour. And instead of just giving the solution away, like I mentioned earlier, I want to work through this and see how I have to change my strategy as I'm going along. So let's take a look. We have a little bit of hint here. We have a line down here. Maybe this is like a return statement. We have an if statement here. Okay, so maybe I need to reread the spec about what the pour method does and see there's something that is conditional. And then we have some line here. Maybe that determines what we're checking here. Okay. So the big if statement seems to be whether or not there's excess liquid. So let's, like previous, let me go ahead and do amount filled plus amount. And we need to compare this to capacity. So let's say I go ahead and I store this. Well, I might want to store this as a Boolean, make the comparison now, but I would still have to just pass in the Boolean in the if statement anyway. So instead, I'm going to store this as an integer, and I'm going to call this answer. And then let me say that the if statement is if there's excess, we're going to do some stuff to it probably. So if answer is greater than amount filled, or actually is greater than capacity, sorry. Then we're going to do some stuff in here. Otherwise, if it's not, then we're just going to be returning 0. Wait, okay, but it seems like there's already a bit of a problem here. We need to return 0, but what happens if amount filled wasn't already at capacity? For example, let's say amount filled was 5 and then we pour 7. We don't just immediately, let's say amount filled was 5 and then we're pouring in 3. We don't just return 0, we need to actually change amount filled to 8. So somewhere in here, we need to change amount filled. And maybe you're thinking this if statement should be the other way around, answer is less than capacity. But then the problem is we're not going to be able to do the things that we need to do if there's excess, right? We don't have enough lines here to fill it to capacity and then return the excess. So instead, what we're going to do is we're going to do two things in one in this line, and we're going to effectively change amount filled directly, and this way we can use amount filled instead of a placeholder variable like answer. So to break down what just happened, we were approaching it one way, where we stored an answer that we were going to use in a comparison in the if statement to determine whether or not there's excess. But because we did not have the lines needed from the skeleton, we had to change our strategy a little bit. So that way we can still increase amount filled and we can return 0 in just 2 lines. And now we're looking at whether or not amount filled is greater than capacity. Well, what do we need to do if the amount filled is now greater than capacity? Because now we have too much within the water bottle. Well, we do a couple things. One is that we need to return the excess, which probably means we need to calculate the excess. And the other thing that we need to do is we need to set the amount filled to the capacity, right? On the example over here, we're setting amount filled to 10, which is the capacity. It's the max that it can be at. And similar to what we did in part A, where we do the strategy of recording the answer, and then we set amount filled, and then we return the answer, we're going to go ahead and first calculate the excess, then set amount filled, and then return the excess. And you might be saying, well, isn't that convoluted? Why don't you just set amount filled and then return excess directly instead of breaking it apart? Well, to calculate the excess, we're going to be using amount filled. I'll go ahead and start typing so maybe it makes a little bit more sense. So we want to store this integer excess as amount filled minus the capacity, right? Because, and we know this is going to be a positive number because amount filled is greater than capacity in order to hit this if statement. And then we want to set amount filled to capacity. And then finally, we're going to be returning excess. And I hope that now what I was saying earlier makes a little bit more sense. If we had done this line and then immediately return amount filled minus capacity, well, then you're always going to be returning 0. What this allows us to do is we basically capture what excess is, store it in a variable, modify amount filled, and then we return excess. I mentioned earlier that I was going to sort of demo what was happening, and so I'll go ahead and do that. Let's say I create a water bottle, W, and I'm going to create a new water bottle. Well, I could pass the default constructor, but then it'll use a default capacity of 16. So instead, I'm going to pass in 10. And then I'm going to set w.amountFilled equals 5. And then if you execute w.pour on 7, which now we've implemented, well, the result should be that if I print what w.amountFilled is, well, I should expect 10. To make this a little bit easier on myself, I'm going to go ahead and put in a little bit of a string in front of it. So I'll put amount filled. And then the next line, I'll print, let's see, we need to print what we're basically returning. So I'll store the result of w.pour in an integer called answer. And then I will clarify that this is going to be the excess If I go ahead and run the main method, give it a second to build. Okay, well, it looks like we have some errors in part C, but if I go ahead and comment all this out and try one more time. Perfect. We now see that it is amount filled is 10 and excess is 2. And in fact, if I take a moment and I go ahead and step through what's happening and I decide to debug it, well, then I can go into the Java visualizer. I see that water bottle W equals new water bottle 10, nice. I step over, we create that new water bottle. We set w.amount filled to 5, perfect. Now we're going to be calculating w.pour of 7. And then we see that the amount filled is 10, the capacity is 2, and then we're storing our answer as 2. And then we have the excess as answer. And I'll go ahead and stop and rerun actually, because this time we can step in to what's happening at the pour line. So if I step in, we see that amount filled, we're increasing to 12. Because it's greater than the capacity of 10, we now store the excess right here as 2, and then we set amount filled back to the capacity, and then we return the excess. So basically exactly what we were thinking was going to happen ends up happening, and that wraps up part B